Okay, cool. So I have two functions. I have the sketch shows y is equal to 1 over x minus 1, which is our hyperbola. So you're going to take your highlighter and you're going to highlight them. Okay, and then the other one we're going to get to now. Let's look at y is equal to 1 over x minus 1. So let's see how it moved. We want the movement. We want to see why it moves the way it moves. So xy, if x is 1, what is y? If I've got the simple function, very simple function of y is equal to, that looks like an e, y is equal to 1 over x. So before we put this minus 1 in, when y is equal to 1 over x is 1, y is 1. If x is 2, y is a half. If x is 6, y is 1 over 6. So can you see, as x gets further along, as it gets bigger, as x gets further along, y gets smaller and smaller and smaller and smaller into fractions. If I've got x to be 1 million, minutes, y is going to be 1 over 1 million. But can y ever reach 0? Can y ever reach 0? Can y ever reach 0? Can it? Can it ever reach 0? Let's see. The real question is, can x be 0? No, it can't. You can't have a number over 0. Okay? It's undefined. So, y can never be 0. Y can never be 0. And that's for the function y is equal to 1 over x. So it can get infinitely small, infinitely small, to 1 over almost infinity. 1 over infinity, it doesn't really exist, but 1 over infinity, it can get crazy small. But it never reaches that 0 because x never reaches that 0. Now, you say, but why on this one does it cross over and y is 0 over here? And you say, but that doesn't make sense now. But it does, because the original graph looked like this. Where's my pen? The original graph looked like this. But what did I do to the original graph? I minused 1 from it. Whatever I minus from it, it moves the whole graph, the whole entire graph, down by 1. If I added 1, it would move the whole graph up by 1. Oh, the electricity's back. From load shedding. So it moves it all down by 1. All of it comes down by 1. And that down by 1 is very important because I can see that y is equal to 0. The x-axis is actually called y is equal to 0. Why? Because red pen. Because this is 0, y is 0 here, y is 0 here, y is 0 here, y is 0 here. So this is actually, the x-axis is called y equals 0. Okay? So, the whole thing has moved down. So y is equal to 0, or the x-axis, used to be the asymptote. It can go infinitely close, but it cannot touch. That asymptote has been moved down by 1. Now the function can go infinitely close to minus 1 on the y-axis, on this lovely axis, but it can't touch it. So it cannot touch y equals minus 1. It cannot touch it. No touching, no touching, no touching, no touching. So this tells us, very importantly, this tells us This tells us what happens to the original one. Originally, this was actually, oh, hello. Originally, this was, pretend that's a straight line. I'm getting used to this pen. That was y is equal to x. Okay, and it reflected a bit around there, and around here, and around here, and around here, and around here. And the asymptote was y is equal to 0, or it was the x-axis. Now the whole thing has been moved down by minus 1. If this was a minus 4, it would be moved down by minus 4. It would be moved down by minus 4. If this is a plus 5, it would be moved up. This function would be moved up by plus 5 from the 0. From the 0, it would be moved up by 5 if it was plus 5. Okay, and that would be 5. And then, instead of my asymptote being at 0, my asymptote would be, if it was plus 5, would be at y is equal to 5. So you would not be able to touch y is equal to 5. Okay, cool. So, that's just explaining that a little bit. How do I get that off my screen? Oh well. Okay, let's look at the next function. The next function is g of x. Oh well. Yes, please. G of x. Where's my pen? Why is it not wanting to go around there? Okay, g of x is equal to ax plus q. Now we know that that a is actually an m because this is a straight line. Mx plus q. And this is can turn out to be an easy question. Why? Because they give us 2 points. Whenever you get 2 points, you can work out your gradient. If I've got y, let's really get used to this pen. Okay, if I've got y is equal to mx plus c, you're going to use a and q. You're going to use a and q. How do I get this off? Yeah, cool. Y is mx plus c. You're going to use a and q. I'm just showing you that it is a straight line. So, if they give me a point, I can't find both of these. I can't find both of these if they've got 1 point. But if I can find this one, then I've got a number for this, a number for this, a number for this, and c. So I've got c is equal to 4 plus 3 plus 2, whatever the case would be. Then I can find c and not have c is equal to x plus m plus... If you've got more than one variable, you can't find the variable easily. So, what am I going to do first when I'm looking for my gradient? I'm going to take the points. This beautiful, beautiful. You know, this was actually made by Isaac Newton. He was wanting to understand something or graph something in physics, and he went, well, how am I going to find the slope of this thing? It was like velocity versus which is distance time divided by time. Just for interest sake, v is equal to distance divided by time. In other words, 50 kilometers per hour is your velocity. And he went, but if I'm working on a graph and I need gradient, I'm going to need... Gradient is rise over run. Very importantly, gradient is rise over run. How many x's? How many y's for each x? So if I'm going this way from here, if I go x1, how many per that one on the y graph? x1, how many y's are over there? x1, how many y's? x1, how many y's? Run over rise over run. Okay, how many y's per x? That as our movement, because this whole graph is about movement. How does it move? It's never stagnant. As soon as it's stagnant, it's just a point. And so this is movement, and that's why, this is very interesting, that's why the graph was originally intended for pretty much time. The x-axis was intended for time because time keeps moving. And if I have eat Smarties per amount of time, if I drive per amount of time, how many kilometers, if I throw a ball up, how many seconds does it take to go up and down in its acceleration, in its velocity, and whatever. So it's really, really interesting. Really interesting. X used to be pretty much to show time. So it's moving. There's a lot of movement happening. And if you cancel the movement out, you just have a point. And just having a point is nonsensical. Well, for now. Later on. Why is my pen? Oh, it's turned off. Is it turning off? It's brand new. Okay. Maybe it needs to be charged. Okay, cool. So movement. What is my gradient doing? What is my slope doing? What is my rise over run doing? And how do you work out rise over run? This beautiful equation that Newton came up with, m is equal to, if you've got 2 points, y2 minus y1 over x2 minus x1. If you can see where this is in terms of y, why did that happen? Where this is, what does that mean? Where this is in terms of x, where the y is in terms of x here, where the y is in terms of x here, you can see what the gradient is doing. How many y's per x. Now, it looks like I'm drawing a squiggle, but this is a new pen. I'm not sure how to make it draw straight. Okay, so I've got 2 points. y2 minus y1. What's y2? y2 is, very nicely, why is it doing this? Work. y2 is 4 minus, now put that minus in. Please put the minus in. Please, for the love of all that is holy, put the minus in. I'll tell you why. Because of the wonderful things he does. Because this but might be a minus 4. And if you leave that minus out, your whole sum is screwy. Because you're going to say 4 plus 4. Oh, well, it's 8. And that's the answer here. But if you left out this minus, you would have said 4 minus 4, it's 0. The gradient is 0. 0, that's nonsensical. How can the gradient be 0? It's even at a point somewhere, gradient has got to be something. So please, for the love of all that is holy and good, keep your minus in there. Okay, so 4 minus 4, which is 8. Okay, cool. 8. Let's take a different color. Hello. And x's? Let's see. The first x is 3. Oh, for the love of all that is holy and good, add your minuses. Minus 1. Minus times a minus is a plus. 3 plus 1. So I've got 8 over 4, which means I've got 2. Now you could have used this one minus this one. It would have given you the same thing. It would have given you like a minus 8 over minus 4, which would have given you the same gradient because those minuses would have cancelled out. If you took this number as the y2, and you can go and do that sum for yourself to check out, to make sure that you can see that it's true. Okay, so what is my gradient? My gradient, or my A, is 2. This sum of newtons is beautiful. Beautiful. M is equal to y1, or y2 minus y1 over x2 minus x1. Beautiful equation, because I've got a point here, minus the y's, minus the x's. You're minusing, it's the change, delta, This triangle is change, in the change in y over the change in x. And change means y minus y. How did it change? How did it move? This whole graph is about movement. Once we see that this whole graph is about movement and how does it move, then you got it. You got all the functions for grade 10, 11, and 12. If you see it as something that's moving, very important, it's moving. Okay, cool. So, Q. Very easy to find Q. Now that we've got M, you can find Q. Q, me and you'll see my name on your PC. Used to be a song. I know that you like me because you're still online. Wow, that's a really old song. I think it's by the Finkelsteins from South Africa. Okay, so Q is equal to... Oh, show that A is 2. Yes, we've shown it's 2. Fantastic. Now, if you mess this up, I'm going to say screw it up, but I don't think that's nice language. If you mess this up, it's okay. Put that into equation. If you can't find that A is 2, make it 2. Y is equal to AX plus Q. Put the 2 in, so that you can at least prove the Q is minus 2. This is for 2 points. If you've messed this up a little bit and you can't prove it, fine. Use this to find this. You'll still get 1 mark. You'll still get a mark right. Okay? So always use whatever they tell you, even if you don't prove it, so that you can get the next mark. Okay, cool. So prove that it's Q. Very easy. I like this red. Feeling the red. Use it. So, y is equal to 2x. Even if you didn't prove it, just use it. Plus q. This q is just c. It's not doing much of anything else. It's just c. So, I can put a point in. 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 I can substitute. I can use it via substitution. But I'd rather just put a point in. So, let's pick a point. We don't want a point that gives us a 0 here. Just remember in future, you don't want necessarily. If you've maybe got a graph like this, because this, well, you can actually. Here we go. It would be C. Okay, let's put that A in. Let's put that A in. I'm not sure what happened there. Oh, why is it coming back and then going away? Okay, so I will get professional in this. This is my first time, so let's see how it goes. We've got point A. So let's see. Y is equal to 2. Let's just make that 2. Y is equal to 2x plus q. Let's put that in. Minus 4 is equal to 2 minus 1 plus q. So, minus 4, remember, whatever we do to this side, we've got to do to this side. So, I have minus 2 here, so I'm going to plus 2 so that I can, so that I have, hello, what just happened? Someone teach me how to do this, please. Someone teach me how to do this, please. Okay, it's much better if someone teaches you than you having to learn via default. That's pretty much the law of everything. That's why you should read books, because someone spent 30 years reading up and learning and falling and failing and falling on their asses and their face, and asses are not a nice word, sorry, and their face and everything, and they can give you all that experience by reading their book. So read books, biographies, and books where people speak about their life experiences and learn from it. It saves us a lot of time in doing things by elimination and by falling and failing. Okay, cool. So, side notes. Plus 2, I've got a plus 2 here. That's why your teacher says, okay, minus 4 plus 2. She says, okay, add it that side, but it's actually that you're balancing the books. You got to, why is this happening? You got to balance the books. Okay, you're balancing the books. Balance this side to this side equals Q. So minus 4 plus 2 is minus 2 is equal to Q, and that's your even just 1 mark. But as long as we know how to do it. Okay, cool. Determine the values of x for which f of x is equal to g of x. Fantastic. It means let's make them equal. This needs to come down. Okay, I will learn how to do this. Someone teach me. It's much easier than me failing. This is Samsung Notes, so I must look it up on YouTube. So, this is for 4 marks. Nice. It's where this is equal to this. Now that we know the equation of this, it makes life much easier. And even if you don't get these 2 points, put them in, because you'll get the next marks. You'll get the next marks if you know these 2 points. Okay, so this is y is equal to, how does it do that? Y is equal to 2x minus 2. I will learn how to do this. Okay, 2x minus 2. Y is equal to 2x. I wonder if it's going to give me equals now. Let's learn how to do that. 2x minus 2. And let's write this one out. Cool. Red. Good. Okay. This one is equal to 1 over x minus 1. So these 2 graphs become equal. Okay. So I go, let's take out that y, because the y's are the same. So this is where these 2 are equal. And where are they equal? Okay, so solve for x. Solve for x. You just got an x here. Solve for x. So 1 over x minus 1 is 2x minus 2. So 1 over x is equal to 2x. I've got a minus 2 here. I'm going to add 1 both sides. That's basically what I'm doing. Although your teacher says take 1 over, that's good accounting. That's good accounting to say add 1 here, add 1 here. So 2x minus 2 plus 1 is how much? Minus 2 plus 1 is minus 1. Okay, I will learn how to do this. Okay. Or maybe it's this pen. I have to press really hard with this pen. Maybe I didn't buy the greatest pen, although it is expensive. Okay, minus 1. Okie dokie. So 2x minus 1. Now how do I get this x on its own? How do I get it on its own and out of this fraction? This says 1 divided by x. So I've got to times the side by x over 1 in order to do this. Then I've got to times this side by x over 1. It's just good accounting. Whatever you do to the one side, you do to the other. Whatever you debit, there's always got to be a debit for every credit. Okay? So, the answer would be yellow. Okay, so I've got 1 on this side. 1 is equal to 2x squared, because I've put an x there, minus, I've got to put an x there, x. Aha! I can see there are going to be 2 points for x. Why? Let's see. There's going to be 2 points for x, definitely, because, check it out. Check it out, check it out, check it out, check it out, check it out. There are 2 points for x, because it's squared. So 1 minus 2x squared minus x. Cool. So I've got I've got a 2 and a 1, and let's write it out nicely actually. 2x squared minus x minus 1 equals 0. Okay, 2x squared minus 1 minus x equals 0. So I've got a 2 here, a 1 here. How do I get to 1? Obviously 1 and 1. I need a minus 1. So I'm going to say plus and minus, because if I say minus and minus, it's going to give me a plus 1. If I say plus and plus, it's going to give me a plus. So I've always got to have a plus and a minus. If I have a minus here and a plus here, 2 times 1, 1 times 1, 2x plus 1, and x minus 1. Cool. So x over here is going to be a half. It's going to be minus a half. Okay. Or x, and we need to work a little bit on our equation so that we know where this comes from. But that's another lesson altogether. Or x is equal to 1. I spent a lot of money on this pen, and it doesn't seem to be all that great. Okay. So x is a half, or x is 1. Minus a half, or x is 1. X is minus a half, or x is 1. Okay. So determine the values of x. Let's see. Determine the values of x for which f of x equals g of x. So the values of x would be minus a half or 1. Cool. And that was for 4 marks. Let's see what's next. For what values? Okay, cool. For what values of x is g of x? What values of x is this g of x? This one here. Bigger than f of x. Bigger than f of x. Okay? So, which values of this is this bigger? Normally, this question comes from that question, or it comes from that question. They're all on top of each other. I needed the q and the c to be able to work out f of x. Same for this. I need these in order to work out, I need all of these in order to work out that. Okay. So, what is this point? Let's see. Purple. What is this point? The C. The C. This C, the x value would be minus a half. We've just proven that now. Come on, pen, work with me. This D value is going to be, this D value is going to be 1, because we just proved that. Okay, this x value. So for which x values is this graph, this G, where's, from here, oh, come on pen, from here, this G is increasing, but this F is decreasing. So while the one is increasing, the other one is decreasing, G of x is going to be bigger than f of x. So x is going to be bigger or equal to minus a half, but it stops at this 0 point. X is 0 because why? Because this function, I'm saying hoekom, because y is the axis. Okay, this function is going infinitely close to this y. Infinitely close, but infinitely close. So it goes infinitely close to 0 is x is 0. Okay, so red. So minus a half is smaller or equal to x, which is smaller, not equal to 0 because it goes infinitely close, but it doesn't touch that x, that y-axis where x is 0. Okay? And then another place, at this D, at this point D. At this point D is 1. If I have, I've got the pen perpendicular now to maybe that'll work. What is this point? This point is 1. So I've got x can be bigger. Can you see this one is increasing? What is the movement of this one? Is it the question you're going to ask is it increasing? Is it increasing or is it decreasing? Or is it decreasing? Okay? Is it increasing or is it decreasing? Maybe I should get the Samsung pen. Is it increasing or is it decreasing? And that's what you've got to ask yourself. Is it increasing or is it decreasing? So, what's going on with the movement? Here it's increasing, but this one is decreasing. So, the values where this one is bigger than this one is x is bigger or equal to 0. So all of these x's forever, for eternity and eternity and eternity and eternity onwards. This is going to increase forever while this decreases into minus infinity, minus 1 over infinity. Okay, so if you have any suggestions for smart pens, this is very expensive, but it doesn't seem to be doing the job. Okay, cool. Calculate the length of BE. Now, if they tell you that it's parallel to the y-axis, if it's parallel, yeah, if it's parallel, that means that this x point is going to be the same as this x point. Very importantly, this x point is going to be the same as this x point. Okay, so x point, exactly the same. So this x point is 3. This x point is also going to be 3. Okay, so I can gooi that point in. Okay, let's gooi this point in. So we're going to say this is the purple. This is the equation. I'm going to put my 3 into there to find out where we are. So y is equal to 1 over x minus 1, 1 over 3 minus 1. To make sure you don't make a mistake, you can say 1 over 3 minus 3 over 3. And you can say y is equal to 1 minus 3 is minus 2 over 3. Okay, so y is equal to minus 2 over 3. Where 3, now we're not working on this g here, we're working on this. Where the x is 3, the y is going to be minus 2 over 3. So this point at E is going to be, the x coordinate is 3, the y coordinate is minus 2 over 3. Okay? 3 minus 2 over 3. Now, you're not done yet. We still have to find, come on, cooperate, please. We're not done yet. Oh well. We're not done yet. We still have to find the length of it. So I've got this point. I've got this length, which is 4. Because this y is 4. So that's 4. But then this length, between this x-axis, y is 0, and the actual point will be minus 2 over 3. So I got 4 and minus 2 over 3. 4 and minus 2 over 3. So let's see. 4 my next point is minus 2/3. Now, if you've got the equation, you can say y1 minus y2, and those two minuses will make that a plus, and say 4 plus 2/3, and you go, oh, what is that equation? That's weird. You can also look at it and just say, this is 4 units. Is this going to come back? No. This is 4 units, and this is 2/3. Come on. I don't want this pen. Why? And come on, why? It's turned off. Sorry. So, and this is, what is happening? This is 2/3. So I can add 4 plus 2/3, which means that this will be 4 and 2/3 is the full length of this whole thing. This moved up. I don't know how this moved up. How do I move it up? Whatever. Someone teach me. Okay, so this full length is 4 and 2/3. Okay, cool. And that's the length of BA. And that was 3 marks. Nicely done. It takes a bit of logic as well, and also practice. You've got to practice lots of these sums to really understand how it moves, how the graph is moving, graph is moving. So, let's get this. Write down the equation. Oh, here we go. Here's an equation. Write down the equation. Often, write down the equation will be after you know like a whole bunch of stuff, even after 5.3. They'll say write down the equation. So if h, write down the equation of h. If h of x is equal to f of x plus 3. So what's f of x? F of x is this one. Now it's already been moved down by 1. It's already been moved down by 1. Can you see that this is only 1 mark? It means you don't have like 100 calculations. This has been moved down by 1. What do? I add 3 to this. F of x is equal to 1/x minus 1 plus 3. That's how easy it is. Wow, I need a new pen. I just bought this pen and it's not Ayoba. Okay. 1/x minus 1, not Ayoba. Minus 1 plus 3 is how much? Exactly, it's 2. So, this new equation will be h of x. New equation will be h of x is equal to 1/x plus 2. That's the new equation. Just add 2. They added minus 1 to the original. They said minus 1. Now we adding 3 to there, which takes us up by 3 to minus 2. So that's asymptotes used to be at 0. They took it down. It used to be at 0. That asymptote used to be at 0. They took it down by minus 1 here. So the asymptote now becomes minus 1. Now I want to take it up again. It doesn't affect the fraction. It affects where this and this is concerning the x-axis. Okay, so now they've taken it up again by 3, but I'm already at minus 1, so minus 1, 1, minus 1, 0, 1, 2. So now everything goes to 2, which means the asymptote now is at y equals 2, because it's moved up 3 from the way they changed it. Cool. Okay, if you've got any suggestions for me about pens, please give me a suggestion. This pen is not Aoba. It's not the Samsung pen. I think I need the Samsung pen, but apparently this does iPhone and Samsung. I hope that helps. Toodles.